press.
Good morning, students. Today I am going to explain about instrument transformers. The instrument transformers are basically meant for measuring high voltages and currents. The instrument transformers are basically classified into two types: the potential transformers and the current transformers. The potential transformers are also known as voltage step-down transformers, or simply voltage transformers or instrument transformers. In potential transformer, the voltage of a circuit is reduced to a lower voltage for measurement. Now, the high voltage is stepped down by using the step-down transformer, and across the secondary, the voltmeter is connected for the measurement purpose, and the reduced voltage is measured by the voltmeter, right? And basically the potential transformer is an electromagnetic device which used for the transformation of high voltages to lower voltage, called a potential transformer. There are capable of these potential transformers are capable of increasing and decreasing the voltage levels of a circuit without changing its frequency and windings. The construction and working principle of potential transformer is similar to the conventional power transformer, and this is the circuit diagram for the potential transformer for the measurement of high voltages. Now here the high input voltage that to be measured is applied across the primary of the transformer, and this high voltage nearly 13.8 kilovolts is applied across the primary, and this voltage is stepped down to a very lower voltage approximately equal to the 0 to 120 volts, and this reduced voltage across the secondary is measured by using the voltmeter. The potential transformer consists of the primary winding with more number of turns and the secondary winding with less number of turns. Results, it works as a step-down transformer. The AC input voltage in kilovolts is applied across the primary, and the reduced voltage or the step-down voltage is measured by using the voltmeter across the secondary winding. And the primary and secondary of the potential transformers are magnetically coupled to each other without any connection between them. The potential transformers are connected with high quality to operate at low flux density, low magnetic current, and minimized load. When compared to conventional transformer, it uses a large number of conductors and an iron core. It can be designed for the form of a core type and shell type to ensure the highest accuracy. Usually, core type potential transformers are preferred to transform the high voltages to a lower voltage. It uses a coaxial winding to reduce the leakage reactances. As the potential transformers are operated at high voltages, the high voltage primary winding is divided into small section terms to reduce the insulation cost and damages. The phase shift between an input voltage and output voltage should be monitored carefully to maintain a lower voltage by varying the load. Windings covered with varnish, cambric, and cotton tape to reduce the insulation cost. Hard fiber separators are used to separate the coils. Oil-filled bushings are used to connect the high voltage potential transformers to the main lines. The primary windings of potential transformer has a large number of turns, whereas secondary windings has fewer turns. Right? This is the So this is the working of the potential transformers. The potential transformer connected to the power circuit whose voltage to be measured. We are already seen in a figure. And the voltage to be measured, that is the high voltage is applied across the primary winding, and that high voltage is stepped down by using the step down transformer, and the step down voltage, it is in the limits of measuring by voltmeter, is measured by using the voltmeter, right? uh, Now the burden of a potential transformer, the burden is the total external volt amperes load on the secondary at rated secondary voltage. The rated burden of a potential transformer is a volt amperes burden which must not be exceeded if the transformer is to operate with its rated accuracy. The limiting or maximum burden is the greatest volt amperes load at which the potential transformer will operate continuously without overheating its windings beyond the permissible limits. The burden is several times greater than the rated burden. Now the current transformer. The current transformer is a device used for measurement of high currents. The current transformer is a device that is used for transformation of a current from a higher value into the proportionate current to a lower value. The transforms the high voltage current into low voltage current, due to which the heavy current flows through the transmission line is safely monitored by the ammeter. The current transformer is a type of instrument transformer that is designed to produce an alternating current in its secondary winding, which is proportional to the current being measured in its primary winding. Current transformer reduce high voltage currents to a much lower value and provide a convenient way of safely monitoring the actual electrical current flowing in an AC transmission line using a standard ammeter. The principle of operation of a current transformer is slightly different from an ordinary voltage transformer. Unlike the voltage of transformer looked at previously, that this current transformer consists of only one or very few turns as its primary winding. This primary winding can be of either single flat turn, a coil of heavy duty wire wrapped around the core, or just a conductor or bus bar placed through a central hole as shown. Due to the type of arrangement, the current transformer is often referred to as a series transformer, as a primary winding which never has more than a very few turns is in series with the current carrying conductor supplying load. The secondary winding, however, have large number of coils, wound and laminated core of low magnetic material. This core has a large cross-sectional area so that the magnetic flux density created is low using much smaller cross-sectional area wire. Depending upon how much the current must be stepped down, as it tries to output a constant current independent of the connected load. The secondary winding will supply current into either a short circuit in the form of an ammeter or into resistive load until the voltage induced in the secondary is big enough to saturate the core or cause failure from excessive voltage breakdown. The construction of a transformer. The core of the current transformer is built up of the lamination of silicon steel. For getting higher degree of accuracy, the permalloy is used for making the cores. The primary winding current transformer carry the current which is to be measured, and it is connected to the main circuit. The secondary winding of the transformer carry the current proportional to the current to be measured, and it is connected to the current windings of the meters or the instruments. The primary and the secondary windings are insulated from the cores and each other. The primary winding is a single turn winding and carries the full load current. The secondary winding of the transformer has a large number of turns, and 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 the and and the the ammeter is connected in series to the secondary winding. And this is the circuit diagram for a current transformer. Now the three-phase, that is the primary winding with very less number of turns is connected, and the current to be measured is across the secondary, and the ammeter is connected in parallel to the in series to the secondary winding. This is the symbolic representation of a current transformer. And the ratio of the primary current and the secondary current is shown as a current transformation ratio of the circuit. The current ratio of a transformer is usually high. The secondary current ratings are of the order of 5 amperes, 1 ampere, and 0.1 amperes. The current primary ratings vary from 10 amperes to 3000 amperes and more. The working principle of current transformer is slightly different from the power transformer. In a current transformer, the load impedance or burden on the secondary has slightly different from the power transformers. Thus, the current transformer operates on secondary circuit conditions. And this is about the voltage and current transformers. And we will continue in next class the applications of potential and current transformers. Thank you.